So what is an NFT? NFT stands for non-fungible token. And non-fungible basically means that each one is unique and can't be identically replaced. So for example, if you have one Bitcoin, which is a fungible token, you can exchange it for one Bitcoin and you'll have the exact same thing. NFTs are often thought of as like a one-of-a-kind trading card, for example, that it's considered non-fungible. So if you trade it for a different card, it's not going to be exactly the same as the one you had. And if you copied it, it would not hold the original, the same value as the original. So the CIP009 sets the standard for an NFT on Stacks. The name of the trait itself is CIP009-NFT-trait. When you implement this into a contract of your own, it doesn't really matter what the name is, so you can name it something different if you wanted to. The main thing is that the functions outlined here need to conform within your trait in your project. When you define an NFT, you also have to pass it an ID. So every NFT has to have an ID. This is done so that we can uniquely identify each NFT. The ID can be anything. It can be an unsigned integer. It can be a string. It can be really anything you want, any type. But for the CIP009 NFT, it's best practice and kind of like a consensus that you use an unsigned integer for an ID, which kind of makes sense, right? It makes it easier to manage. You can have IDs 1, 2, 3, 4, going all the way up. It's pretty straightforward, and it becomes easy to identify who owns NFT of ID number, whatever. So let's take a look at these required functions for the CIP009 trait. So from top to bottom here, we see get last token ID. This is a read-only function that returns the token ID of the last NFT that was created or minted by the contract. So pretty straightforward there. Get token URI. This is also a read-only function. It takes a single parameter of an unsigned integer. And what it does is it returns a valid URI link, which resolves to a metadata file for a particular NFT. So often this metadata will be stored on IPFS. And it can have whatever attributes you want it to have, right? So it might have, for example, a link to the image file itself. It might have the name of the artist. It might have specific attributes for each NFT, and so on. The standard, the CIP009 standard, doesn't provide a specification for what should be in the URI. And if the passed in ID, so that parameter that gets passed in, if it doesn't exist, it just returns none. Next, we have get owner, which is a read-only function that takes a single parameter of an ID and returns the principal that owns that NFT. And then finally, we have transfer, which takes 3 parameters, an unsigned integer, and then 2 principals. And this, well, as the name implies, just transfers ownership from one principal to another. If the ID that is passed in as an input parameter doesn't exist, then it just returns an error response. So these are the standard, I guess, like base functions necessary for NFTs. So to define an NFT within your contract, you need to have at least these functions defined. MJ, I saw you asked, does it have to be in IPFS? It does not, no. Okay, so we are going to go through and write out a very simple starter NFT contract. You guys are welcome to code along with me if you want. I'm going to code it out line by line. So if you want to follow along and do that together, you can, or you can just watch. Or this exact code is also available in the Clarity Camp repo that we have on GitHub. So if you want to just pull that down and follow along on there, you can do that as well. Okay, cool. So I'm just going to create a new project called Nfp. And open that up. Oh, whoops. Hang on. Okay. Cool. All right, so you guys should be seeing my VS Code now. Let me know if you don't. But all I did was just create a new Clarinet project here named NFT. So as you can see, I have like my starter template here. So first thing we're going to do is we're going to create a contract for our NFT standard. Excuse me, sorry about that. So I'm going to create a new contract, Clarinet on, oops, contract new. And I'm just going to call it SIP 009. Okay, there it is. So this file, all it's going to do is essentially hold the definition for our SIP 009 trait. So this is, I'm literally just going to copy paste this from the repo. You can grab this from the Clarity Camp repo. The same kind of template is also listed in the SIP repo itself. So, you know, it's always going to be the same. So you can just copy paste that in, and this is just defining our trait and then the necessary functions for it. Okay, so once that is set up, I am going to create another contract, which is where we're actually going to write our code. So I'll just name this one NFT. And cool. So this is where we're going to build out our little sample NFT. So the first thing we need to do is we need to implement the trait. If you guys remember from Monday's session, Akanksha went over implementing traits. So we have our trait defined here, our SIP 009. We need to implement it in our contract that we'll be using it in. So trait identifier is going to be the contract followed by the trait name. In our case, so I have SIP 009. And then my trait name is SIP 009. Cool. So as soon as you define this in here, you're gonna notice an error already. If it pops up, invalid signature for method get last token ID regarding trait specification SIP 009. So Clarinet is recognizing that you're implementing a trait, but it's immediately telling you, hey, you need to have all of these methods defined and you don't. So that's what that error is telling you right here. Okay, so the next thing we're going to want to do is define our NFT, right? So we can use define non-fungible token, which takes the NFT name and the NFT identifier type. So like I said, every NFT has to have an ID. The type can be anything you want, but typically best practice is to just keep it as an unsigned integer. So I'm going to call this my NFT, and the identifier type is going to be unsigned integer. Okay, so that's it. We've already defined our NFP. Next thing I'm going to do is define some constants that I want to use for my project here. So first, we're going to define a constant which is going to represent the mint price. And to keep it simple here, we're just going to set it to U100. Okay, so this is going to represent the price for each mint. Next, I'm going to define a constant. So for this example, we're going to demonstrate how you might like split the payment, right? Split the however much is paid for the mint price between multiple people, right? So say we have the project creator and then the artist, and we want each one to get a portion of the mint price. So I'm going to define a constant. I'm going to call it wallet 1. And for this example, we're just going to go into our DevNet file and just copy paste addresses from here for testing purposes. So I'm going to grab the deployer address and copy that. And he's going to go right there. And this is going to represent, let's say, the creator, right? The project creator. Then I'm going to define a second constant, which we'll just name wallet 2. And again, I'm going to, hang on, let me move this little toolbar out of the way. Okay. Again, we're going to go into DevNet, and I'm just going to snag the second address here. And this will represent, let's say, the artist. Okay, so we're defining 2 separate addresses that we want the stacks that are paid as part of the mint to go to. Okay, so I think that we can start looking at writing out our methods now here, our functions. So the first one that we have is get last token ID, which, as I said, will just return the ID of the last NFT that was minted or created. So that kind of, based off of that, we know that we're going to need to store this, the ID somewhere in our project, right? So we need to store the last token ID. And essentially what's going to happen with this last token ID is that it's going to increment each time a NFT is created, right? So each time a new one is created, the ID is going to change to a new number. So that being said, can somebody tell me if we would use a constant to define our last token ID? And if yes, why? If no, then why not? Yep, exactly. Yeah, so constants can't be changed once they're defined, whereas a variable or a var is initialized with a specific value, and then it can be changed as needed within functions, right? So yes, we're going to define a variable. We're going to name it just last token ID. Then type is just going to be an unsigned integer, keep it simple, and then we're going to start it with a value of 0. Right, so right off the bat, we don't have any NFTs, so that's going to start at 0. Cool. So now we can go ahead and start working through our functions here, starting with get last token ID. So I'm going to create a read-only function. I'm going to call it get last token ID. This one does not take any input parameters. And all this is going to do is use our built-in function var get to retrieve the value of our variable up here, last token ID. Okay, so literally all it's doing is retrieving that value. So we use a read-only function to for this specific method, right? For retrieving this. We could also put it in a public function, right? That's possible. But why does a read-only make sense as opposed to doing a public function? Okay, well, the reason why we are using a read-only function. Oh, wait. Yep, yeah, you guys got it exactly right. So we're not making changes. We're not making any changes to the chain here. So there's no need to do a public function. And also, correct, a read-only function doesn't cost. So a user doesn't have to pay a transaction fee to call a read-only function. So yes, exactly right. Those are the two reasons why it makes sense to use that as opposed to a public. Cool. Okay, moving on. Let's do our next function outline here, which is get token URI. So same thing, this is going to be a read-only because all we're doing is retrieving some data. Get token URI. Now this one does take an input parameter of an unsigned integer. So we're just going to call it ID, unsigned integer type. Oops. And for this, we're just going to say, okay, none, because we don't have URI in this example, right? We're not using one. But if you did, say this was a real NFT project and you did have an actual URI that you wanted to reference, typically the way you'll see that done is you might see something like define data var. We'll just say URI would be of a type string. Let's say the 20, sure, why not? And then you would pass to it a string. If it's IPFS, it might be something like IPFS, right? I think that's how it is. And then some link right there, and then potentially whatever the ID is linked to that. So you would have, if you had an actual metadata URI that you wanted to pass in, it would look something like that, right? So just define it up at the top, pass in the link, and then you could just use var get to get your URI value. But since we don't have one, we're just going to leave it as okay, none for this example. Okay, next would be get owner. So again, we're going to do a read only for this one. Get owner. This one also takes an input parameter of an unsigned integer. Oops. And for this one, we're going to use a built-in function called Nfpgetowner. So this is the function that is provided to you already. And all it does is retrieve the owner of a specified NFT ID. So it's asking you for the asset name, which in our case is my NFT. That's what we called it up here. And then the asset identifier is going to be whatever ID is passed in as an argument. Cool, that looks good. All right, and finally we have transfer, which takes 3 inputs, an unsigned integer, and 2 principals. So for a transfer, this one is going to be a public function because we will be making changes, right? We're going to be transferring ownership of a specific NFT from one principal to another. So our function transfer, first input is an unsigned integer, which is going to represent the ID. Second input is the principal, the sending principal, and then the receiving principal. So we're going to say sender of a principal type, and finally a receiver, which is also a principal type. Okay. And in here, all we're going to do is use another built-in function called Nfp Transfer. This one's created for you already. And all it does is transfer ownership from one principal to another. So as you can see, this one takes a couple of inputs as well. You have the asset name, which is my NFT. You have the asset identifier, which is going to be the ID that is passed in as an argument. And then the sender, which in this case is sender, and then recipient, we'll switch this to receiver. Cool. So we have our NFT transfer. We're giving it the name of the NFT, and then we're passing in these input parameters that are coming in as part of the function call. Okay, cool. So one thing I do want to point out here, you guys may have noticed as I wrote out these functions that all of these I manually gave it an okay response, whereas this one I didn't, and it's not giving me any errors. If I did clarinet check, it should pass. Yep, it passed the check correctly. And that is because Nfp Transfer returns a response as part of the function. So I'm going to drop real quick in the chat the docs for the different built-in functions in Clarity. And if you, as you look through them, you know, if you like search for Nfp Transfer, it'll show you the output, and it is a response already. So I don't need to manually do the response. It provides it for me. Okay, so looking at our example now, we have actually, at this point, already created a NFT as according to the SIP 009 standard, right? So we have our 4 functions here that are part of the standard. So at this point, this is a standardized NFT on Stacks, right? So this is the minimum that you need to create your own NFT project. We are going to write out one more function though, which although it's not part of the standard and it's not considered like, it's not required as part of the standard, it's something that most people want to do when they think of NFTs, and that is to mint one, right? So we're going to write out a function to mint a new NFT here within our little project. So this is going to be a public function. We're just going to call it mint. And we are going to give it one input parameter, which is going to be the recipient. So the person who is minting the NFT and receiving ownership of this new NFT. And it's going to be a principal type. And okay. So there's a couple of things that we are going to want to do as part of our mint function. So the first thing that we're going to do is we're going to use the let function, which I believe you guys went over maybe last week's session while I was gone. But essentially, let allows you to define local variables within your function, right? So we're going to be doing that here as an example. So we want to define two variables here. The first one is going to be an ID, which we are going to set to an incrementation of our last token ID up here. So the way that we increment, we're going to use our Polish notation, right? So we're going to say plus, and then we're going to pass to it the two expressions that we want to add together. So in this case, we're going to use var get last token ID and unsigned integer 1, right? So what we're saying here is add up the return, like whatever you retrieve from last token ID, so whatever this is currently set to, and add 1 to it. And that's going to be the value of ID. Next, we're going to define the amount that we want to go to each of our wallets, right? So how much do we want to go to the creator? How much do we want to go to the artist? So we're just going to call this portion of total. All right, so this is our name here, and we're going to set that, again, using Polish notation, to divide the mint price, which we defined up here in our constant, right? So we set our mint price to 100. We're going to divide that by 2, right? Keep it simple. So assuming it works correctly, then each of our wallets should get 50 sats upon mint. Cool. So we've defined that. Next thing we're going to want to do is, of course, as part of the minting process, is that we want to make sure that the appropriate number of sats or amount of sats gets transferred to, from the purchasing wallet to wherever it needs to go. So we're going to use try, right? Oops, hang on. So we're going to use try, which attempts to unpack the response of the expression within it, right? So we're going to try and STX transfer, which is a built-in function that just attempts to transfer a certain amount of sats from one principal to another. So the amount is going to be portion of total, which we defined up here, right? So we're going to attempt to transfer whatever this is, right? Mint price divided by 2 from the sender, which in this case is whoever's calling in, whoever's gaining ownership of the mint, right? So somebody's calling into mint, they want to purchase it and become the owner. So we can assume that they're going to be the ones paying for it in this case. So the sender here is going to be our recipient. And then our recipient of the sats transfer is going to be our wallet here, right? So we've already defined our first wallet. So project creator here is going to receive the first portion of the transfer. And then we can do the same thing for wallet 2, right? So here what we're saying is we're going to try to transfer this amount from the recipient taking ownership of the NFT to our predefined wallets that we've defined up here. And if you guys recall, try is one of our functions that can be used to exit the control flow, right? So try is going to try to unpack whatever is returned from this, which STX transfer is going to return either OK or error, depending on whether it was able to transfer the appropriate amount of stacks or not. And then if try gets an OK response, then cool, it moves on to the next line. If it receives an error response, then it'll exit the control flow and stop the function execution. Cool. And so now we can assume that we have transferred the correct amount of stacks to each wallet that we have defined. Now we're going to try one more thing, and that is the actual mint, right? So we have a built-in function for that as well that is created for you, nice and easy, Nfp mint. And what this does is it creates or instantiates a new NFT and assigns ownership to the recipient that is passed in, right? So Nfp mint takes an asset name, which in our case is my NFT, an asset identifier, which in this case is going to be the ID that we define here, right? So our ID, which is the last token ID +1. So our asset identifier will be ID. And then our recipient here can actually stay the same because we define it as recipient. So the person that's taking ownership of the NFT. Cool. So at this point, going line by line, we can assume that if everything has worked correctly, we have transferred the appropriate amount of stacks to each wallet, and we have successfully minted an NFT and assigned ownership to the recipient or the receiver or the caller, however you want to refer to that. So one more thing that we want to do is we want to update our last token ID variable that we defined up here, right? So we want to make sure that each time a new NFT is minted, this gets set to whatever that new ID is. And we can do that by simply using var set. So we're going to set last token ID, and then the value will be ID, which is represented here, right? So this ID is keeping track of our increment, and we're setting our global last token ID to whatever that new incrementation is. And finally, we're just going to say OK and ID. So our response should be OK, and then whatever our new ID is. And assuming that I got that all right, we should be good to start testing it. So let me do clarinet check. Yep, looks good. So let's pop into the console and test our mint and see if it's working the way we expect it to. All right, so first thing here, we can see our NFT contract. We can see the functions that we're expecting, and then it is recognizing our SIP009 trade as well. And then we have our assets table here. So first thing I'm going to do is I am going to change my TX sender. We'll just pick this guy down here, because I want to assume that I'm just like a user coming in to mint. Whoops. What didn't it like? Next sender. There we go. Okay. Cool. So we switched our sender to just this random guy down here. And now we can go ahead and make a call to this. Yeah. And then mint. And that takes one input of a recipient, which in this case is me, right? I want to mint the NFT, so I'm just going to pass in TX sender. Cool. So we can see some events took place here and our response of OKID. We got OKU1, which hopefully means that it worked correctly because we incremented our ID here. So now if I do get assets maps, awesome. So we can see here that a new NFT asset has been created. And me down here, this address that I switched to owns 1. And I have also transferred out 100 sats, 50 of which went to this first address, 50 of which went to the second address. So let's go ahead and test our transfer here real quick as well. So I'm going to change the TX sender again. And we'll just take this guy. And I'm going to make a contract call again to mint with TX sender, which should now be this new address. Awesome. And our ID incremented to 2. So we can assume that we have 2 NFTs minted. And sure enough, now this address owns 1 and this address owns 1. And our creator and artist wallets up here have both received an additional 50 stacks. So our mint function seems to be working well. Let's take a look at our transfer. I want this. And now transfer takes a couple of input parameters. It takes an ID. So let's say we're going to transfer the second NFT that we minted. The sender, which is me in this case. So we can just say TX sender. And then the receiver, we're going to transfer this over to this guy down here. Oops. Whoops. Oh, I forgot my single quote. Okay. So assuming that this works correctly, now our AZ6 address should own 2 NFTs, and this guy should be down to 0. Yep. And yeah, so that is pretty much our example for an NFT. Very simple, straightforward. Of course, if you're building an actual NFT project, you might have a bunch more functions that you want to incorporate, but this is like the bare minimum required in order to get started with an NFT mint.